Hello everyone, here is our solution. As the WebGPU standard continues to mature, the official WebGPU standard will be released in the next quarter. More and more developers in the community pay attention to the development of WebGPU. So we decided to make a series of video tutorials to help you understand the basics of WebGPU and our experience during development. Today, we will briefly introduce what WebGPU is and the developing environment configuration. First of all, let's briefly introduce the background of WebGPU. So what is WebGPU? As the name implies, WebGPU uses JavaScript to control GPU to calculate and draw on the web. It is a new API standard defined by W3C organization. This standard has been supported by all browsers and device manufacturers. Under this organization, people could participate in the development of WebGPU standard. WebGPU is expected to be supported by all major platforms. Why is it named as a new generation of graphics API? Comparing with the current graphics standard, WebGL, WebGPU applies modern graphics APIs, which refer to 3D Direct, Vulkan, and Metal. If you don't know these three things, it doesn't matter. For beginners, we just need to know that WebGPU is faster, more powerful, more flexible than WebGL. And the most important thing is, WebGPU is more in line with modern web development standards. There are many technical comparison reports between WebGL and WebGPU on the internet. So here, I will mainly introduce the history of WebGPU through the development of WebGL. Firstly, let's thank Xiaojia Wei from the Intel graphics team. He helped us to make a summary of WebGL and WebGPU development at Google's Steadfast conference last year. We will understand the development of WebGPU by looking into three key timestamps in this figure. Now let's look into the first key timestamp. WebGL standard was proposed in 2011. It is an implementation of OpenGL ES2 on the web, which is actually another specific implementation of OpenGL2 on the mobile side. In other words, WebGL is an implementation of OpenGL standard in 2004. After several years development, although we now have a newer standard WebGL2, but in fact, according to this figure, you may easily tell that it is an implementation of OpenGL 3.2 in 2009. As we can also see from this figure, WebGL is using an OpenGL framework system more than 10 years ago. Actually, OpenGL itself is a very old standard. It has nearly 30 years history. WebGL is an implementation of OpenGL ES2 and 3 standards. It can no longer make good use of the framework with modern GPUs, and there is no way to meet the required high-performance computing and rendering needs. In 2018, Apple announced that it would abandon the entire OpenGL framework, and around 2015, Apple, Microsoft, and Kronos launched the Metal, D3D12, and Vulkan based on the new GPU architecture individually. These three are now referred as the modern graphics APIs, which is a watershed with the previous OpenGL standard. The majority of 3D games and 3D rendering we know are developed based on these three APIs. So when W3C organization proposed the new web graphics standard, it also applied with these three new graphics APIs and abandoned the entire framework of OpenGL. They did not choose to upgrade WebGL into standard 3.0, but redesigned a new framework standard WebGPU. After this year's development, the question is how WebGPU is supported in those major browsers. Until March 2022, Google benefits from its own open source project Dawn and adapted WebGPU to Chrome very early. So far, from the Chrome version 94 to the latest version 101, they have provided GPU support on the desktop side. Firefox is very similar to Google. It also set up an GFSRS team to start a project to adapt Firefox to WebGPU with Rust. In the Natalie build version, which is their developer preview version, provides support to WebGPU on both desktop side and Android mobile system. As for Apple, one of the earliest WebGPU technicians, they also did the WebGPU adaptation work in the Safari WebKit very early. So now they have provided public testing of WebGPU in certain versions, like technology preview versions, supporting both iOS and Mac system. As you may know, some remaining major browsers include the Microsoft Edge and domestic browsers. They are actually customized development based on the Chrome kernel, so they have no plans for WebGPU development at present, and they will highly likely choose down as the implementation of WebGPU directly after the WebGPU official version is released. As beginners, it is enough for you to know this much about WebGPU and are ready to carry out development work. Next, let's introduce how to configure a basic WebGPU's development environment. First of all, as a web development, a browser is essential. Second, you may need a code editing tool IDE environment. So here, we recommend using Chrome as our main browser because currently Chrome support for GPU is the best. It supports the latest WebGPU API standards and also the latest syntax. As for IDE, we recommend Microsoft Visual Studio Code because VS Code has comprehensive plugins, and its support for WebGPU is also very good. Besides, itself is powerful, simple, and easy enough to use. In addition, we recommend using Vite as our front-end code building tool. Compared to Webpack, Vite as the star open source project in 2021, it is many times faster than Webpack in terms of packaging and compilation. And because we are developing WebGPU projects, we don't have to consider compatibility with the old browser standards, so using Vite can greatly increase our development speed. We'll introduce some basic usage of Vite in the example project later. We will use JavaScript as our main developing language, and there may be a small amount of HTML and CSS to do some front-end layout. We will use TypeScript for development as well. We choose TypeScript mainly because it can help us to check whether the WebGPU API is used correctly and whether the input and output meet the standards. So if you don't know much about TypeScript before, don't be afraid. We will show you some demonstrations in the following tutorial. Finally, we may also use a new language, WGSL, short for WebGPU Shader Language. It is a new shader language proposed by WebGPU. Don't be afraid if you don't know this before. Again, all of these examples in this video are very simple. I believe you will understand in a short time. And we will give detailed explanation in the meanwhile. Finally, of course, we need some system environment. If you are using Windows, then it's CMD. If Mac or Linux, then it's terminal. We also need to know some common development tools, such as Node.js, NPM, and Git. We will not introduce too much about the use of these tools in this series of tutorials. Those who are interested in can visit the relevant official websites listed below to download and learn by yourselves. Believe me, they are not difficult. But note here, we recommend using Chrome Canary for WebGPU development because it applies the latest WebGPU syntax and APIs. For your convenience of learning, we made a development template based on Vite. You can visit our Evolution official GitHub repository to download and learn. We also upload all the demos in this repository demonstrated in this series of tutorials. Next, I will show you how to install the template and some basic key points. I've directly used the terminal window in VS Code. You can also find the terminal in the menu here to create a new terminal. Then, in the relevant directory, you can tap git clone and attach our URL to download the entire development template. After the download is completed, enter the development template directory. Run npm install to install all of the related dependencies. Then, type npm dev to start a dev server locally. Then we opened localhost 3000 in your browser. We should be able to access a Hello WebGPU demo. Okay, we can take a quick look into the structure of the entire project through the README file. One of the important ones is the source folder. We will put all the TS source code and WGSL shader code used in this demo into this directory. In addition, we will put all the HTML in the sample directory, which is an entry file. This HTML is quite simple. Apart from a simple CSS style, it is mainly used to code our TS file. We'll give a detailed introduction later. Then, the other two important files, one is in package.json, and the other is tsconfig.json. Package.json indicates some basic information about our project. The more important part is that it indicates the dependencies of the project. In this tutorial, we install the basic TypeScript and Vite packages. And also, we install an official definition package of WebGPU TypeScript. We'll briefly introduce this definition package later. Then, after these installations are completed, we need to refer these definition packages in tsconfig.json file. The content in the tsconfig file is generated by the Vite template automatically. All these attributes are a default attribute for TS. We'll introduce this in detail when we use them. So here, we mainly need to define this tabs attribute. The package WebGPU tabs we installed needs to be quoted here. Additionally, we also need to code an official definition package of Vite, which may not be used in this video. When we use the relevant syntax later, we'll give a detailed introduction. Now, let me introduce this Hello WebGPU demo. Here are two takeaways that need to be mastered. I'll empty the code and take you through it again to help learning. So the first point, how to determine whether a browser supports our app or whether the WebGPU is available in the current environment. According to the WebGPU specification, if the WebGPU is available, we should be able to obtain a GPU object in navigator.gpu. In this way, we can tell whether WebGPU exists. If it is equals to undefined, then it proves that WebGPU is not available. We can type a log here, say, not support WebGPU. Otherwise, for example, we can say hello WebGPU. See, after we save this, Vite will automatically refresh it for us. We can see the log in the console. It types the string of hello WebGPU, which may be a bit smaller to be detected. So let's say we directly override the document body now, and then let it equals to a h1 tag hello WebGPU. Now we can see it easily. For our own convenience, we can directly judge non-navigator.gpu. If it is not existed, we throw a new arrow, which is more convenient and simpler to code. In general, we recommend to use throw arrow to terminate this statement. It is better than coding if-else. One reason is that it gives us a feedback about this arrow in logs. Secondly, we don't have to wrap it in the parentheses to save some codes. Besides, this arrow can also be called by JS in other places. Then, back to here. If this condition returns false, it means that the current environment is WebGPU supported. then, so we can make the h1 inner body equal to a hello WebGPU again. Okay, this is how we determine whether a browser supports WebGPU. The second key point today is that most of the WebGPU APIs are asynchronous. So how do we program asynchronously in the TS code? We firstly take a basic WebGPU API as a sample, which is the Navigator API.request adapter. Here, we don't need to know what this API does. We'll introduce the use of WebGPU APIs in detail gradually. All you need to know here is that this request adapter API is asynchronous, and it will return a promise. By the way, let's briefly introduce a basic feature of TypeScript in Visual Studio Code. You see, when I hover my mouse on this API, it'll give us a tooltip about a detailed description, including what parameters are passed in this API. It can pass an option or not, and it will return a promise. The object returned may be a GPU adapter or none. This is given by the features of TypeScript for us. The reason why TypeScript knows this information is that we installed the WebGPU tabs package, which is a customized field. It defines the names of the parameters required by each WebGPU API, the type of parameters, the types of returns, and etc. So we can directly get the detailed attributes of each API here. If we come back to the TS config file and don't call this, or if we didn't install WebGPU tabs package ever, you can see that the Visual Studio Code will report an error because it can't recognize the GPU attribute in Navigator. Because WebGPU is a new standard. Currently, in general IDEs, there is no information about the GPU field in Navigator, so it will report an error. Let's bring this WebGPU tabs package back, and we'll get all the helpful parameter details. Okay, let's come back to the TS code. This request adapter API will return a promise. So how do we deal with promise? We need to know the basic usage of JavaScript. Dealing with promise belongs to the foundation knowledge of JavaScript. We will not introduce this in detail here. Instead, we'll do the coding directly. The standard way to deal with a promise is to use the then function to catch it. And in this return value, we also need a callback function and return its parameters. Let's have a look into parameter descriptions of this request adapter API in the tooltip. It should return an adapter or none, but no matter what is it, we must first catch this adapter. As we code here, it's actually not very convenient. We recommend use arrow function to do this. Arrow function is a new syntax of ES6. We also use this a lot in the future tutorials. If you're not familiar with it, please first learn the use of arrow functions. Okay, after obtaining the adapter, we can easily log this adapter. The detailed information and usage in the adapter will be discussed in the next video. So what we mainly want to say here is that after the adapter is obtained, when we request it again, it is still an asynchronous function, such as the function of adapter.requestDevice. Then it will also return a promise. So if we're using this traditional catching promise method, using the then callback, we may need another then callback here to get a device. So this kind of callback function, wrap another callback function, is a very bad way to code. I believe developers who have such experience in JavaScript could know that this kind of callback will be troublesome. A slightly more advanced way of coding is to return this promise. In this way, we can call this returned promise in its parent level to make another callback function. This is called a chain callback. But in fact, it's not convenient either to code this way because many of the APIs are still asynchronous. Then these asynchronous functions will also encounter the similar problem like many then functions. Our code will contain a bunch of then functions. It will be very messy. Besides, then function has an internal scope of its own. If we want to use some context relationships and some global variables, it will be very inconvenient. So the main second point comes out here. As most of our WebGPU APIs are asynchronous, in modern JavaScript programming, we recommend using the async function to handle promise. Let's compare the difference of the above code snippet if we use async function. For example, we first create an async function named as init WebGPU. Then after declaring this async function, we can use the await keyword in the function to change an asynchronous programming into a synchronized programming. For example, if we request an adapter, we can directly catch it and assign it to another variable. In this way, we code a then callback function to call an adapter. Looks like a synchronized call. Similarly, adapter can directly obtain the device with this wait keyword. As you can see, during my entire programming process, thanks to the reference to the definition from TypeScript WebGPU package for TypeScript, Visual Studio will give us an automatic field parameters, which is very convenient for us. It will help us to avoid bugs. Why there is a question mark? Also the above statement here. Some people may have already noticed and asked why there is a question mark. This is actually a forced check by TypeScript. As this function, it may return none. That is to say, according to the definition of this request function, it does not always return an adapter as we want. It may return none in some cases. So this question mark here is actually a shorthand. This is a new JavaScript syntax feature. We can actually check it traditionally, just like checking if navigator.gpu exists. For example, let's first check if non-adapter. If adapter does not exist, it is maybe a none. We could still return a new arrow, say no adapter found. This time we don't need this question mark because running this command assured us that the adapter exists. As we know already, the above adapter has two optional tabs. It may be GPU adapter, then we go through this command. It will automatically recognize that the adapter must already be a GPU adapter tab rather than a noun. So we use a question mark, which is actually a shorthand to check. However, we recommend using this throw arrow method in the project, especially in the learning process, because we not only need the syntax correct, but also need an arrow feedback. If you don't code this, there is no feedback on this new arrow. Well, after coding this, if something goes wrong, we can get an error report. Okay, let's compare these two pieces of code. It is obvious that this method of await and async function is much simpler. Especially another big advantage is if we want to return this adapter and device, we can return them easily. For example, we return the adapter. Then when another function calls this init WebGPU function, we can easily get the adapter variable. We define a function run here. Then we can also use the await init WebGPU function to get this adapter. Comparing to this, then callback function is very difficult to pass out the relevant parameters. The approach to resolve this is to apply for a global variable in the web or a global variable relative to the then function scope, such as global adapter. Here we don't pay attention to the syntax. The way to resolve this is after the callback, we can make this global adapter equal to the adapter that passed out the parameters in this way. This is a very troublesome thing. So using async functions, we can gracefully deal with the problems caused by several asynchronous functions. In all the following tutorials, we will use await to deal with most of the promises. Unless there are some special cases, we will use then function. I will give a detailed explanation when we use them. Okay, this is the two key points we need to understand after this video. One is to check the GPU field in the navigator to see if it supports WebGPU. And a basic way to deal with the asynchronous WebGPU APIs using async function. There are some other files in this repo we haven't introduced yet. This is mainly to print some corresponding information. We'll introduce the meanings of these limit fields of adapters in more detail in next video. Okay, in our next video, I'll introduce you how to draw a basic triangle through WebGPU. Then through the next tutorial, we'll understand the basic process of a WebGPU configuration and some common API usage. Thanks for watching and welcome to subscribe to our Revolution channel. I'll see you next time.